Good morning, learners. I will be discussing with basics of metrology, and I am Vemuri Venkata Phani Babu, Associate Professor, Department of Mechanical Engineering, MLR Institute of Technology. Today, my topic will be types of measurements and methods of measurements, in which the types are direct comparison, indirect comparison, comparative, coincidence, fundamental methods, contact methods, transposition methods, complementary methods, deflection methods, and contactless methods. All these are different types of measurements. See, my heading was types of measurements and methods of measurements. So these are the types of measurements. Coming to methods of measurements, we will be discussing it. Coming to method, direct method. As the name itself is saying, direct. So the measurements are directly obtained. If a scale is being used to measure any length, so in that there will be gradations, and from the gradations, which means from first point to last point, we will be saying it directly. So here I have shown you as a vernier calipers. There is digital vernier calipers where the distance between this jaw and this jaw is being directly displayed with LED. Right? So indirect method, as it is indirect, it is obtained by measuring other quantities such as measurement of strain induced in a bar due to applied force. These are obtained quantities. So this is not direct reading. So this first, from this displacement of strain gauges, we will be having separately one display where we will get it as an indirect method. Coming to comparison, so it is compared with other known values. So for example, all the comparators which we are using will be in the comparative method. Coming to coincidence methods, measurements coincide with certain lines and signals. As example, comparators here also, but what we have used here is vernier calipers, right? So this is a vernier scale in which we will be going for 0.02 mm accuracy. Coming to fundamental methods, measuring the quantity directly related with the definition of that quantity. This is fundamental. So if I say this room is of 10 by 10 by 10, it is of square feet, or it is of meters, or whatever it is. I will be mentioning it after my numericals, this one. So coming to next method is transposition method. Quantity to be measured is first balanced by a known value and then balanced by other new value. So many have gone to any market where they will be weighing over this one. So you have seen that one known value of 1 kg stone will be kept at one of the pan, and other onions or tomato will be kept at the other known. So one is known quantity and one is unknown quantity. So by this we will be telling that as a transposition method. The example is determination of mass by balancing methods. Now coming to complementary method, the value of quantity to be measured is combined with the known value of the same quantity. So determination of volume by solid by liquid displacement volume. So for this we can say if something has been dropped in a bucket or something like that. So how much of water has been spilled, that quantity will be exchanged with the weight of that particular part which has been dropped on it. Coming to deflection method, deflection. So it is nothing but, deflection is nothing but the movement from one point to other point. So the value of measurement is directly indicated by deflection of a point. So example, my pressure measurement, if nothing was there in the tube where we want to measure a pressure. So if we attach a pressure dial indicator there, when the pressure has been given into the tube, this pointer will be moving out. So whenever this pointer is being deflected to a particular number or something like that, that number can be readable, and that is one of the method of measuring. Coming to contact method, sensor measuring tips to touch the surface, contact. So the sensor will be in contact with the particular surface of that quantity, then we will be using it. So here example vernier calipers, as we said before also, vernier calipers, between two jaws we will be keeping the component which has to be measured, right? So until unless it has been touched both, we cannot measure it perfectly, right? So contactless, without contact, here we can say optical instruments. As I said, laser instruments also came from measuring any quantity. So by sitting here itself without using any tape or scale or any other equipment, by using a simple button of a laser, I can measure all the quantities in my room, in this room, right? So coming to types of measuring instruments. So deflection and null type instruments, analog and digital, active and passive instruments, automatic and manually operated instruments, absolute and secondary instruments, contact and non-contacting type, intelligence instruments. If you particularly see all these types of measurements, they are included with all this, right? So types of methods, types of measuring instruments. Coming to deflection and null type. Deflection, as I said, the pointer will be moving. It will be in a weighing balance or a digital balance directly. So in weighing balance, what we will be doing, we will be keeping a known weight in one of the pan, unknown weight in another pan, right? So the weight of the object is indicated by deflection of a movement of a pointer. Here, if there will be a pointer. If the weight is here is more, then automatically this pan will lift and this pan will be down. So deflection of movement of a pointer on a graduated scale will be there. As I said, we can best example is spring balance, right? So this is spring balance where we can hang a weight here such that this pointer will be moving down. So whatever the reading is at the bottom of this pointer will be the hanged weight of that particular component. So the effect is caused by the quantity to be measured is nullified. Example, consider the measurement of a weight by ordinary beam balance shown in the figure, and this can be compared with this. The unknown weight placed in one side causes the beam of the pointer to deflect. As example, beam balance, right? So analog and digital. This analog and digital, as we are seeing in daily life while riding a two-wheeler or three-wheeler or four-wheelers, we can see. So this is analog in numerical, right? So whenever this pointer is being deflected to 10, 20, 30, if it is mph, miles per hour, or it is kmph, it may be kilometers per hour. So nowadays we are directly using this. And for the new developments, we are also going for digital instruments where the speed or water mph or kmph or volume of the fuel in our tank, everything will be displayed in digital form, directly in digital form, or we can say it as LED displays. Now coming to active and passive types. Active and passive types. So the quantity being measured just activates the magnitude of some external power input sources, which in turn produces the measurement. So in this type, another external energy input source is present apart from the quantity to be measured. In passive types, output is produced entirely by the quantity being measured. So if a float is there, right? So active and passive. Whenever the liquid is being increased or whenever the liquid is being filled in, then the float will be moving up such that it will be giving us the fuel gauge meter reading. Here direct gauge will be there. Whenever the pressure is being applied at this point, automatically gauge will be given. Manual or automatic instruments. See, weighing balance is best manual and automatic. Manual instruments require the service of a human. Here, if you place any weight on this platform, you are supposed to have a human intervention where we can move this on the scale such that it will be balanced perfectly. But when the process of null balance is automated, it is termed as automatic instruments. In this, the same weight, if you keep it here, directly a display will be coming. So here there is no need of intervention at the measuring spaces or measuring quantities. Coming to absolute and secondary instruments. Absolute instruments are those which give the value of quantity to be measured in terms of constants of the instruments and the deflections only. So this is best example for absolute and secondary. Secondary instrument shows the deflection directly in terms of electrical quantity like voltage, current, power and frequency. See here, voltmeter or ammeters. Directly, these instruments are calibrated by comparison with absolute instrument which will be kept at national laboratories. Now coming to contact and non-contact. Contact is, best example is thermometer. So until unless it contacts a heat source, it cannot display any temperature here, right? Until that it will be at room temperatures only. Generally thermometers will be in contact only, right? So nowadays in the COVID period you might have seen non-contacting thermometers also, right? So non-contacting, they will be just keeping near to our hand or face, which will never come into contact to us, but it can give the same reading as well as the contact instruments. So now intelligent instruments. So microprocessor is incorporated with measuring instruments. So why microprocessor? As I said, it is intelligent. So once my biometric or once my iris has been recorded in these instruments, whenever I come and put my biometric or give my eye scan, then automatically it retrieves and it will be saying. Now whereas these are being particularly used for attendance purposes, either in colleges or in government offices or anywhere. Login and log out can be totally calculated by this intelligent instruments. So coming to metrology, as we are saying that accuracy, precision and everything, right? So what is accuracy and what is precision? Accuracy is a measure of rightness, and precision is a measure of exactness. So the main difference between accuracy and precision is accuracy goes for rightness, perfect, and precision goes for exactness, whatever it is there. So measurement is an act of assigning an accurate and precise value to a physical variable. So here I am saying accurate and precise, but for the accurate I will be defining in rightness, and for the precise I will be defining with the exactness. So in a diagrammatical way, what is accuracy and what is precision? So if you see this is not accurate, not precise, right? So accuracy is the ability of instrument to measure the accurate value, conformity, and precision refers how closely individual measurements agree with each other. This is repeatability. Precision will come only in repeatability, accuracy will come if a accurate value has been measured. So in this figure, first ball, second ball, third ball, they are not even accurate. So this is my point where it should be shooted first, right? So even they are not precise also. Since there is no repeatability also here. Now in coming to the second one, it is accurate, not precise. Why accurate is there? In single line or in the second circle they have been placed, but they have not been repeated in the same. So it is not precise, but it is accurate. Now if you see here, all the four has been very close. So it is precise, but they are not in accurate since they are not in same line. Now if you see here, this is my exact point, right? So if you see here, they are inside the circle, so they are accurate, and within them the repeatability is also happened, so it is even precise. So accuracy and precise are two different words, where accuracy says that it measures the accurate value, and precision says that how individual measurements agree with each other, that is repeatability is being done. So if generally if anybody have been gone to any metrology lab or somewhere where we will be measuring length and diameter of any equipment, generally we will be asked to take 3 times, right? So we will check whether this 3 times accuracy is coming or not, or repeatability is coming or not. So we will be taking an average so that we will be giving the final output of that measurements. So coming to the factors affecting accuracy and precision of a measuring systems. So as I said, accuracy and precision. So there are 5 basic elements which we will be calling them as SWIPE. So SWIPE is S stands for standard, W stands for workpiece, I stands for instrument, P stands for human, that is person, E stands for environment. All these 5 basic elements, that is SWIPE, will be affecting our measuring system. Standards of them, workpiece standards, instrument which we are selecting to measure, person, that is human interaction, and environment also will be a separate one. So coming to separately, what is standard? So how that standard will be affecting? In this slide we will be discussing about S, that is standard. So it will be the coefficient of thermal expansion, and it may be depending upon the stability with time, it will be having elastic properties of the equipment which we are using, and positioning of it. These standards, these 4 standards will be affecting our measuring system. Coming to workpiece, the cleanliness of the surface finish on top of the workpiece, and the surface defects which are already existing or it may constitute while transporting it, and the hidden geometry of the workpiece. These all 3 also will be affecting our measuring system. Coming to instrument, that is I, it should be having inadequate amplification, then scale error has to be eradicated, deformation while handling heavy work pieces, calibration errors, repeatability and readability has to be done, and checked with instrument. So as I said, standards, if you remember standards, right? Primary standard, secondary standard, and workshop standards. All this has to be readability and repeatability should be there for them. So coming to person, that is human. Humans, for every equipment they need particular training skills, and they need to have sense of precision appreciation, then ability to select measuring instrument and standard for a particular measuring, then attitude towards personal accuracy achievements. Then they have to plan for measurement technique to have minimum just with consistent in precision. So always we should go for precision than an accuracy, accurate. Coming to final factor, that is environment. So all factors of environment like temperature, pressure and humidity will be affecting on measuring equipment. Even it should have clean surrounding and minimum vibration has to be maintained. Adequate illumination, that is lighting, should be there perfectly while reading it. Temperature and equalization between standard workpiece and instrumentation should be there. All swipe. So see here, higher accuracy can be achieved if all the 5 factors are considered, analyzed and steps are taken to eliminate them. Only when this 5 is being met, then only the particular equipment is used, and that particular reading will be acceptable overall. So coming, as I was saying, accuracy and precision, everything. So if precision is not there, then error will come. If accuracy is not there, then error will come. So what are errors in a measurement? So what is error in a measurement? Measurement error, that it may be observational error, and that is nothing but the difference between a measured actual value and its true value. In scale, I will be seeing directly and saying it is 10 centimeters. But if I see somewhere in an inclined way, it may be a 9. So this measurement, that is observation error, is the main error in measurements where we will be getting. If you are going for true size, theoretical size of a dimension is which is free from errors, then it will be called as true size. If coming to actual size obtained through a measurement with permissible error. So for every equipment within permissible tolerances, we will be manufacturing. If that tolerance is there within the limit, then this permissible error we will call it as actual size. So types of errors in measurements can be divided into gross and blunder errors, then measurement errors. So gross and blunder errors are totally not acceptable. So further we may divide measurement errors into systematic and random errors. So random errors, it will be coming randomly. So we cannot again bifurcate this error. So systematic errors we will be bifurcating into instrumental error, observational errors, environmental errors and theoretical errors. Environmental, observational, instrumental and theoretical errors. Gross and blunder errors. This category of errors include all human mistakes while reading, recording the readings. The best example of this error is a person or operator reading pressure gauge 0.01 Newton per meter square as 0.10 Newton per. See, 0.01 and 10. There is a lot of difference. This is human error, right? So recorded is this, but reading was this. So it is a gross and blunder error. So we cannot tolerate this. Coming to measurement errors. The measurement error is a result of variation of a measurement of true value. So usually measurement errors consist of random error and systematic errors. Systematic errors, as we said, measurement errors are divided into systematic and random errors. Coming to systematic errors. A systematic error is a constant error that under same operating conditions. It can be caused by any factors that systematically affect measurement. It may be instrumental error, environmental error, observational error and theoretical. So in the instrumental error, it may be calibration error of the particular instrument. Environmental error, as I said, environment which consists of temperature, pressure and humidity. And observational, it is parallax error method, that is visual angle. Theoretical is percentage, what percentage the error is being done. So random errors, these random errors, with these random errors we cannot control at all. We are not taking them into consideration at all. They are caused by uncontrollable fluctuations and variables that affect experimental results. So fluctuations are there means we will never go. They are caused by sudden change in experimental conditions, maybe noise, tiredness of the working process. These errors are either positive or negative. So maybe one time random error may be correct, but one time most probably they will be nullified, or we will not consider them at all. These errors are reduced by taking the average large number of readings. So the repeatability has to be more. The repetition of the measurement for a particular workpiece by a particular instrument has to be done repeated several number of cycle times. So in this class we have discussed about the types of measurements, methods of measurements, and also types of measuring instruments. We have defined accuracy, precision, and what is difference between accuracy and precision. Then the factors affecting a measuring system. The factors affecting a measuring system in terms of accuracy and precision, and what are the errors in measurements and types of errors in measurements. Right. Thank you for your time. I will take leave for this.